Bond energies. Chemical reactions involve breaking of bonds and making new ones. That's what is involved in chemical reaction. You break all bonds, then you make new ones. The amount of energy it takes to break 1 mole of a bond in a compound is called bond energy. In the gaseous state. So the delta H reaction can be estimated by using bond energies. We can use bond energies to estimate the enthalpy of reaction. Trends in bond energies. The more electrons two atoms share, the stronger the bond of the covalent bond. So for example, carbon triple bond, you see the bond energy is 837 kilojoules. Carbon nitrogen is 891. But these triple bonds are larger in energy than the double bonds, and the double bonds are larger in energy than the single bonds. The shorter the covalent bond, the stronger the bond. And when it's stronger, it has more energy. For example, bromine fluoride, its bond is longer than bromine and chlorine, and is even is shorter. Bromine fluorine is shorter than bromine chlorine, and it's shorter than bromine bromine, and it even affects the energy. Bond gets weaker down the column. Using bond energies to estimate heat of reaction. We want to use bond energies to estimate the heat of reaction. The actual bond energy depends on the surrounding atoms and other factors. We often use average bond energies to estimate the heat of reaction. Works best when all reactants and products are in the gaseous state. Bond breaking is endothermic. I want you to take note of that. It means it is positive. And bond making is exothermic. That is negative. So delta H reaction is the sum of the bonds broken plus sum of the bonds formed. Take note, bond formed is negative and bond broken is positive. So let's find the heat of reaction of this reaction. So this is a molecule. You have to break this bond. That's the carbon-hydrogen bond. And you break the chlorine bond to form a new carbon-chlorine bond and a new hydrogen-chlorine bond. So those are the bonds that we are going to be looking at. Let's get their bond energies. So we are going to go to this table, get the average bond energies before we do the calculation. So carbon-hydrogen bond, let's look at carbon-hydrogen bond. So 1 mole bond breaking carbon-hydrogen bond, 1 mole of carbon-hydrogen bond from the table is plus 414 kilojoules. We got it from the table. The next bond that is broken is 1 mole of chlorine bond. Let's see where it is. This is it. It says is equals to, is that it? Oh, that's carbon, carbon. We want carbon chlorine, single bond. We have to get it. So this is carbon carbon. We want carbon chlorine. Okay. We'll get it. So this is carbon chlorine. No. Is? No. We want chlorine, chlorine, sorry. This is chlorine, chlorine. Which is plus 243. So total bond energy kilojoules broken total is equal to, let's add it up. You can add it with me, please. So let's work together. 414 plus 243. This gives us plus 657 kilojoules. That's the bond broken. Let's see the bond formed. So the bond that is formed, we have carbon chlorine, okay. One more of carbon chlorine, that's it. Equals to is minus 339 kilojoules. Then hydrogen chlorine, one more of hydrogen chlorine equals to, let's see, hydrogen chlorine, let's find out where hydrogen chlorine is. Okay, this is hydrogen chlorine. It's minus 431 kilojoules. Let's get the total. Minus 339 minus 431. 339, minus 339 minus 431. So that will give us minus 770 kilojoules. So our heat of reaction is this plus this heat of reaction. Is 657 kilojoules plus minus 770 kilojoules. This is equals to so our answer is minus 113 kilojoules. So that's our answer. We go to this table and get those values and do the calculation. So that's our equation. So that's the total we got from the table for bond breaking. This is the total we got for bond making. Then our heat of reaction is minus 113 kilojoules. We can put it in a diagram, energy diagram. So this is the energy diagram of what happened. Delta H1 is greater than 0, you see. Then delta H2 is less than 0. You sum the two, you see. It shows that heat is released. So delta H2 is lower in energy than delta H1. Heat is released. So this is another example. We can do this example also. And when you do it, please try and practice it at home. When you do it, your answer should be positive 136 kilojoules. So estimate the enthalpy of the following reaction. Hydrogen plus oxygen to give you hydrogen peroxide. So try and do that. Your answer should be endothermic, sorry. So we want to talk about bond lengths. The distance, bond length is the distance between the nuclei of a bonded atom. So the distance between the nuclei of bonded atoms. That's what we call bond length. Because the actual bond length depends on other atoms around the bond, we often use the term average bond length. So you can see, look at fluorine. The bond length is 143 parts per million. It starts from the nucleus. The bond length for chlorine is 199 parts per million. Picometers. It's picometers. We are looking at picometers, sorry. Then for bromine, it's 228 picometers. And for iodine, it's 266 picometers. You see, as you go down the group, the bond length increases. So trends in bond length. The more electron two atoms share, the shorter the bond length. So we can see it from this. The triple bonds have shorter bond lengths times the double bonds, and the double bonds have shorter bond lengths than the single bonds. Another characteristic of bond length is that it decreases from left to right across the period. Carbon-carbon has longer bond lengths than carbon-nitrogen, and carbon-nitrogen have longer bond length than carbon-oxygen. Another thing about bond length is that it increases down the column. So bromine has longer bond length than chlorine, and chlorine has longer bond length than fluorine. In general, as bonds get longer, they also get weaker. So we'll see some examples of bond lengths. So these are some examples of bond length. Check the tables, you can see. As the bond length increases, they get weaker. So I want to thank you so much. We've come to the end of what we need for the material for chapter 9. Thank you so much. Please don't forget to answer the odd number questions. You have the answer. Do some practice because this will give you a better understanding of the material. So thank you.